Okay, so let's pick up again. So looking at the solubility curve, what we can see is anything that is below this line, once again, that is going to be an unsaturated solution. If it is on the line, it is saturated, and if it is above the line, it is supersaturated, meaning that it has gone above what it can hold. This next slide that you see here, this talks about the conductivity of certain solutions. What you need to know is that essentially if the substance contains an ionic bond or an ionic compound, such as the ones that have that are listed here, and one thing about those ionic compounds is that all ionic compounds contain a metal. It is the metal within that compound that makes these solutions conductive. It causes them to be electrolytes, or as it says here, strong electrolytes. So strong electrolytes are going to contain a metal. It is the metal within that ionic compound in the solution that allows it to be a conductor of electricity. Looking at acids and bases, we see a table that has the traits of each. It talks about the taste, the touch, the reactions, electrical conductivity, and what's going to happen with a litmus paper. So remember that litmus paper is an indicator. It is a piece of paper that is treated with a chemical, and it allows us to see if something has the presence of an acid or base. If it contains an acid, is that the color associated with acid is red, the color associated with base is blue. You can remember that because bases and blue both begin with the letter B. So if you have blue paper and you put it in a base, it will remain blue. Red paper will turn blue. The opposite is true with acids. If you have a red paper, it's going to remain red, or a blue paper will become red. Both of these can conduct electricity. The thing to remember is, the further it is away from 7, which is neutral, the stronger it's going to be at conducting electricity. Acids are going to react with metals to produce hydrogen gas. And when that does occur, you can have the formation of a salt. Bases are not going to react with metals. Acids are going to feel kind of thin or slippery. I'm sorry, not so really slippery, but just kind of thin, more like water. Whereas bases are going to be a little thicker, and they're going to feel smooth and slippery, kind of like wet soap, which in fact is a base. For the ones that we can taste, you're going to have acids that are going to have kind of a sour taste. Lemonade is a natural acid that we consume many times, and bases are going to be more bitter. Certain substances are going to contain alkalines, coffee, tea, spinach, other kinds of foods are going to be things that are bases. And again, you don't want to taste chemicals unless you're told that it's safe to do so. Take a moment to look over this. This is just talking about what's going to happen when you have an acid-base reaction, what you're going to have. Take a moment to read that, and then we'll talk about what the important points are. Okay, the important thing to point out here is that in looking at this, whenever you have any acid and base reaction, you're going to have the formation of a salt of some type, and you're going to have the formation of water. In many cases, you're also going to have a gas that is also formed. And this is typical with the baking soda and vinegar reaction. You have the formation of carbon dioxide gas. So anytime you have hydrogen ions that are given off, that is going to indicate the presence of an acid. And hydroxide ions, remember the hydrogen ions have a positive charge. It's in group 1. Hydrogen is in group 1, and it has 1 valence electron. But when you have hydroxide ions, hydroxide ions are negative, and they're kind of the opposite of hydrogen ions. And this is going to show you when you have the presence of a base. So many bases are going to end in OH. Acids usually begin with an H. These are some examples of foods or other substances that are natural acids or bases. You can see here, soap is at a 10. You have lemons over here that are at a 2. Vinegar is at a 3, and so forth. Now, a lot of this is also going to depend on the concentration level. Many times these substances are diluted with water to make them a little weaker so that they are not corrosive and harmful. But you might be asked about various examples of these things on your EOC test, so make sure that you're familiar with those. Okay, so let's look at this, this problem right here. We're asked to find the chemical formula for an ionic compound formed between aluminum and oxygen. Take a moment to try to solve that, and then we will come back and talk about it together. Alright, so the important thing to do when you're trying to figure this out, remember that this is going to be an ionic bond. We have aluminum and oxygen. Aluminum is a metal and oxygen is a nonmetal. So remember that the aluminum is going to be a positive ion, and oxygen, because it's a nonmetal, will be a negative ion. So oxygen is going to take some electrons from aluminum. If you look at the periodic table, you will see that aluminum is in group 13. That means that it has 3 valence electrons. Metals are going to give away their valence electrons. Oxygen is in group 16. It has 6 valence electrons. Remember that nonmetals are going to take electrons until they have a total of 8 in the outside. So if it has 6 and it wants to have 8, it needs to have 2 more. So we say negative because it's taking on electrons, and electrons have a negative charge. The aluminum, when it gives away its 3 valence electrons, it's going to have 3 more protons than electrons, so it's going to have a positive charge of 3 positive. Now, to find the correct formula for this ionic compound, and remember that ionic is always going to be a metal plus a nonmetal, whereas covalent is between 2 different nonmetals. Alright? So, to find the formula, you take the oxidation numbers, and basically the oxidation numbers, that's what's going to happen electrically with the atom when it forms a bond. Either it's going to give away electrons or take electrons in terms of an ionic bond. But you take these oxidation numbers and you just cross them over like this, and that gives you the formula. So the 2 goes over here, the 3 goes over to the oxygen, and that should be your formula. And if you look, that is a choice for B, Al2O3. And again, this is called aluminum oxide. Remember that with covalent bonds, you have to use the prefixes like mono, di, tri, and so forth. Alright, let's look at the next slide. And again, please come to class with questions if there's something you don't get so I can explain it to you. Another balancing chemical equations question. So you're going to be asked questions almost just like this. It says, which coefficients of iron and oxygen gas and iron oxide balance this equation? Alright, we're given some examples over here. We're given some choices to choose from. So let's just set it up like this. I'm going to go ahead, I'm going to write down the elements and what we have. So we have iron and we have oxygen. Those are the only 2 elements we have in this equation. I'm just going to go ahead and make my little tic-tac-toe board like this. All right, so let me evaluate what I have currently, and make sure you have an eraser handy so that you can change these around and so forth. I start out, I'm going to look on the reactant side. Remember, we have reactants and we have products. And this is a synthesis reaction because you have two small things that are coming together to make a larger thing. So synthesis is where you combine two smaller components to form something much larger. Decomposition is the opposite, where something like this is broken down into that. But this is synthesis. All right, remember, decomposition is the opposite. All right, so we have 1 iron, and over here we have 2. So remember, if you don't have a coefficient, assume that it is 1. So 1 times 2 is 2. So I already see a problem with iron, but let's look at what else is going on. Over here, I have 2 oxygen, and then I have 3. All right, so both of those are out of balance. Now, when you have 2 numbers, and let's say that one is not the multiple of another, you need to think about what their common multiple might be, right? 2 would be a factor of 4, so I could kind of double whatever I had over there to make that work. But here, I need to try to make both of these 6. So I'm going to think about, if I'm trying to balance this equation, all right? If I'm trying to balance this equation, I want to think about in terms of what's a common multiple between 2 and 3. So if I place a 2 here and a 3 here, and I'll look at my elements and my atoms, what I have. All right, I can see now I have 6 for both of these. Now, when I did that, that turned this into 4 iron. And I can very easily fix that by placing a 4 right here. And you can see that both of my elements are balanced. So I have 4 iron plus 3 molecules of oxygen gas, so that's 3O2. Right? So 3 times 2 is 6. 4 times my imaginary 1 is 4. 2 times 2 is 4. And then 2 times 3 is 6. So it looks like it's balanced right now. So what should I have chosen for my answer for this? I should have definitely chosen D. Now on the test, if you get confused, what you can try to do is you can actually try to just randomly select one of these, put it into the equation, see if it works, and if it does, you have your answer. If not, you can eliminate that one and go and try another one. And you keep doing that until you find the one that works. So there's only 4 to choose from. Just try one, see if it works, and if it doesn't, go to another one. But that's how this is done. Remember that in the situations where you don't have a subscript, pretend that that subscript is 1. If you don't have a coefficient, it's 1. And that's how you're going to balance these equations. All right, so next question. A mixture is created with 5 grams of sugar, 5 grams of salt, and 4,000 cubic centimeters of water. Which is the solvent? All right, so just kind of going through this real quick. We have pure substances, and then we have mixtures. And then pure substances are going to be basically where you have one type of particle. And this includes elements and compounds. And then mixtures, that's going to be everything else. All right, so a solution is a special type of mixture. It's one that looks the same throughout, it's uniform, it does not block light, you cannot identify the individual particles in it, so there's a lot of special things about solutions. But here we have 5 grams of sugar, 5 grams of salt, and 4,000 cubic centimeters of water. Remember that for water, 4,000 cubic centimeters is going to be the same thing as 4,000 grams. Because the density of water is 1 gram per cubic centimeter. So you have 4,000 grams of water, 5 of sugar, 5 of salt. which one is going to be the solvent? And that's easy, that's going to be water. And the way you can think about that, when you look at solute and you look at solvent, solvent has more letters in it. And whenever you have a solution, whatever constitutes 51% or more of the matter that's present, that's going to be what the other substance is dissolved in. So whichever is more is a solvent, whatever is less is a solute. If you were to have, let's say, salt water, because the water constitutes more of what's present, it's going to be the solvent, whereas the particles of salt would be the solute. All right, next slide. This is talking about electricity and what you have to know about that. So this is in your book. I'm not going to go through it and read it to you. But remember, we're looking at the basic knowledge regarding polarity of magnets. We're looking at voltage, Ohm's law, and how circuits are constructed and the difference between series and parallel circuits. So here we can see some examples. We have a series circuit, a parallel circuit. Remember, the two benefits of a parallel circuit are going to be that if one of these wires were snipped, the other two would remain closed, and they would be able to keep moving those charges through the circuit. Another advantage is this. If I have 3 ohms of resistance for each bulb, this circuit has a total of 9 ohms of resistance. So every bulb that I add is going to make those lights a little bit more dim as time goes on. Here, you won't have that issue, because at no point do you ever have more than 3 ohms of resistance. So you're not going to have these bulbs becoming more dim as you add more to the circuitry. Here you will, because you have to combine the resistance, but in this one, since you have 3 separate pathways, you don't have to combine the resistance of the different pathways. Those are not combined. Remember that when you plug something into the wall, that's going to be alternating current with a push and a pull. When you have a battery, that's going to be direct current, because it flows from the negative end to the positive end, and that is the only direction in which it travels. This talks about domains. Remember that only iron, cobalt, and nickel are the substances that actually have domains. Those are not present in other elements. Remember that we can use electromagnetic induction to generate electricity. We'll talk about that in just a moment. Electric motors use rotating electromagnets. Remember that we have a difference between permanent magnets and temporary magnets, and we're going to just talk about all that right now. So here, this is an example of electromagnetic induction used to generate electricity. You have a solenoid, which is just like simply a coil of wire that is attached to a galvanometer, and the galvanometer will measure the presence of an electric current. If I move the magnet in swiftly through into the coil and out, back and forth, it's going to actually generate electricity. So this is how a lot of our electricity is generated and made for us to consume. So again, this is called electromagnetic induction to create a generation of electricity. Here's another example of that. I can take a spool of wire that's twisted, and I can have a magnetic field here between the North Pole and the South Pole. And if I turn this rapidly, if it spins rapidly, it's going to also generate electricity. So this is how we can use a windmill or a large fan where the wind power will blow through it and twist it to make electricity occur. You might notice these near your house. This is a transformer. These can be used to make voltage higher or lower. Now this can only be done with alternating current. This is why we use alternating current in our homes. It's because we can raise the voltage and lower the voltage. We can do both of these. And again, that is through these transformers. So if you've ever seen one of these, that's what it's used for. It's used to make the current higher or lower. When the electricity is produced, we usually make it higher so we can get it out into the area. But before it goes into your house, we have to reduce it to a much lower voltage because your house can't handle that much. So we step it up or step it down according to whatever we have to use it for. Now, here's another way we can look at how a transformer works. You see here we have a variety of coils going around the primary side, and this is where the power kind of comes in, and this is where the energy comes out. So this is kind of like an electromagnet. Here we have we have 9 of these coils. I'm sorry, let's see, 1, 2, 3, 4, 5. We have 8, and then we have 4. So think about 8 divided by 4 is a factor, I'm sorry, 8, yeah, to go from 8 to 4, you divide by 2. So whatever voltage you, say you had 100 volts, you would divide by 2, because that's how you go from 8 to 4. So if you had 100 volts, it would become 50, right? So it's decreasing by a factor of 2. So 8 divided by 4 is 2, so it's decreasing by a factor of 2. You could say that whatever your voltage is divided by. Now you could also reverse this. Let's say you go from 4 to 8. You would double your voltage, whatever it is. Another example of this, same situation. You have, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. This has 16, this has 8. So this is where you're also dividing the voltage by half. And you have to do that because in some cases, wherever you're trying to go with the voltage is going to be too much for whatever the load is, whatever you're trying to power. Another example, this one is the opposite. I have 4 and I'm going to 8. So I'm going to double it. I'm going to multiply it by 2. If I have 100 volts, it becomes 200. If I have 5 volts, it becomes 10. So again, think about the mathematical relationship between these coils and those coils. Are you dividing by a number? If so, what number are you dividing by? Are you multiplying by a number? If so, what number are you multiplying by? So think about how to go from here to here. To go from 4 to 8, I multiply by 2. Therefore, the voltage is also multiplied by 2. Okay, so this is one question. It looks kind of long. I'm going to go ahead and read it to you. As wet clothes tumble in the clothes dryer, friction between the clothing items can knock electrons from some fabrics onto others, creating a static charge. This static electricity can discharge when dry clothes are taken out of the dryer, sometimes causing unpleasant small shocks. The use of dryer sheets can reduce or eliminate this buildup of static electricity in the dryer. Which hypothesis is the best explanation for how dryer sheets reduce or eliminate static electricity? Take a moment to try this on your own, and then we'll talk about the answer. Okay, so let's look at this. If you look, answer choice B states that the dryer sheets are coated with chemicals with a positive charge. These positive charges balance the negative charges that result from friction with the clothes. So what's happening is this positive charge is going to neutralize any buildup of electrons that you have. All right? So this is the best choice. So you're going to have the presence of those negative charges. The only way to get rid of them is to discharge those or balance those out with positive charges.